Hello class, so in this video we're going to talk about polar areas and kind of compare them with those in the Cartesian plane, so rectangular coordinates, how they're similar, how they're different. Alright, so area, same idea in terms of you're going to take a bunch of little things and add them together, and that's what an integral is, right? So let's talk a little bit about integration direction. So the direction of the slices. In the Cartesian plane, you have something like that. You want to find this area. You're taking slices that go downward perpendicular to the x-axis. Or you can get things like this. And you take things toward and perpendicular to the y-axis. And they just stack that way. However, for polars, that's a little bit different because polars are measured this way, right? They're measured radially. So that's actually the integration direction. So it is going to deal with angles and a radius. So that's why here I say we're going to use the area of a sector of a circle. So remember that sector just means got a circle, got a little portion like that. This is a sector. So area from theta equals alpha to theta equals beta is just going to be the area of a bunch of sectors added together. Sectors are 1/2 r squared theta, essentially. And since theta is the thing that we're taking infinitesimally, so we're adding a bunch of those together, that's going to be our differential there, d theta. So to simplify that, well, not really by much, we're just taking out the constant. We have this. This will help you with integrating polars. All right, so let's figure out how to practice and do that. All right, so the main challenge here is finding the limits of integration. Because of the way the polars work, it's not as straightforward as something like this, where like, oh, I see from that to that, those two x values, I'm going to take that integral. But instead, we have curves like something like this can happen. And if you're looking for the area of this outside or just that inside or something like that, it's not as straightforward as just from this point to that point. So we got to figure out what those points actually are. And I say the best way to do that is just graph the shape. It helps you understand what is going on the best. So figure out those special points that you're looking for and figure out the shape's orientation. Like for instance, this one over here, it started here and just went in this direction. So that'll help guide you in figuring out those levels of integration. All right, so let's just start practicing this and see how that actually comes into play. Okay, so with this, let's just start graphing. All right, 0, pi over 6, pi over 4, pi over 3, pi over 2. I'm just going to graph one quadrant first. Let's see what's going on there, and then graph more if necessary. Since this is cosine of 2 theta, we know that that's going to be bounded between -1 and 1. So we can make it so that our scale just goes like, let's just go to the fourth circle here as 1. Okay, so at 0, we're going to get cosine of 0, which is 1. At pi over 6, we get cosine of pi over 3, which is a half. Then cosine of gives us pi over 2, which is 0. And then 2 pi over 3, which is -1/2. And then pi over 2, that gives us pi. So cosine of pi is -1. Let's start graphing that. Start at 1, and then go to a half, go to 0. And then now on the pi over 3, we're going to go -1/2. On pi over 2, we're going to go -1. Okay, so let's see what will happen if we go one more further. 2 pi over 3. So at 2 pi over 3, we're going to get basically cosine of 4 pi over 3. So on the 2 pi over 3 axis, we're going to get -1/2. And if we go further, one more, 3 pi over 4, that's going to be 0. So then it goes right there. So let's just start graphing this first and see what we get. Get a shape that starts here. Okay, hits the inside. And then goes around like this. And it goes back to hit the origin again. So quick thing, what are we looking for? It says we're looking for the area of one petal. Oh, look, conveniently, we have one petal right there. So let's figure out what are the limits of integration for that. Where did it first hit 0? First point is there. Next point is there. So those are our limits of integration. So let's just do that. So area is going to be 1/2 integral from pi over 4 to 3 pi over 4 of the function squared. All right, so easiest thing to do here is just quickly apply the power reduction identity for cosine. So pi over 4 to 3 pi over 4 of 1 plus cosine of double that angle, all divided by 2, d theta. So this can just go out in front, that's 1/4. And then the integral is going to be theta plus 1/4 sine of 4 theta, evaluated from pi over 4 to 3 pi over 4. All right, so then we get 1/4 of the difference between those plus 1/4 of, so let's kind of reason through this real fast before we just do that. So we're going to get sine of 3 pi minus sine of pi. Those are the same angle on the unit. They're coterminal angles. So sine of something minus sine of the same thing is just going to be 0, right? So that actually is kind of irrelevant. So we can forget that. All right, 1/4 of, so that's going to give us 2 pi over 4, which is pi over 2. Multiply that out, we get pi over 8 as our area. All right, so let's go on to the next one. Practice some more. Find the area of the inner circle of this thing. So let's just start plotting. 0, pi over 6, pi over 4, pi over 3, pi over 2. So again, just try one quadrant first, see what happens. Add if you need to. So at 0, we're going to get 1. Pi over 6, we're going to get 2. Pi over 4, we're going to get 1 plus square root of 2. And 1 plus square root of 3. By the way, square root of 2 is about 1.4, so you can estimate this as 2.4. Square root of 3 is about 1.7. Estimate this as 2.7. All right, and then at pi over 2, we're going to get, let's see, 1 plus 2 is 3. So let's just start graphing that. I'm going to make this my scale. So at 0, we're going to get 1. Then we get 2. And then 2.4, 2.7, 3. And then the exact same thing is going to happen. Oops. Because over here, because sine is still positive there. So exact same things, it's just reverse with 2 pi over 3, pi over 4, 3 pi over 4, and 5 pi over 6, and then pi. So let's just do those points out then. Then we're going to get that. So we've covered up to pi. So now let's figure out what happens after that. So 3 pi over 2, 5 pi over 3. Oh, wait, no. Sorry, wrong part. 7 pi over 6 first. 7 pi over 6. 5 pi over 4. 4 pi over 3. And 3 pi over 2. Because this is going to be symmetrical to the next part after 3 pi over 2. So it makes sense to do this first. Or the other one works, but whatever. Okay, so 7 pi over 6. That's going to give us negative 1/2 times 2, so negative 1 plus 1 is 0. Then we're going to get negative, just going to use the decimal there, 0.4, negative 0.7, negative 1. Then that same thing's going to reverse, so we'll look at that later. So 0, and then negative 0.4, so that'll be like there. And then negative 0.7, then 1, then it's going to repeat, then back to 0. And then it's going to get back to 0 at 11 pi over 6. So that means the next point's just going to be the original. So let's sketch that graph real fast. All right, and then the area that we're looking for is that small area, the inner circle. And the two values that do that actually are going to be 7 pi over 6. That's where it first hits 0. And then the next one is 11 pi over 6. And from here on, it's just do an integral and don't mess up on the details. So let's do that. Area equals 1/2 of the integral from 7 pi over 6 to 11 pi over 6 of 1 plus 2 sine of theta, quantity squared. All right, 7 pi over 6 to 11 pi over 6 of 1 plus double their product plus the second term squared. So don't forget to square that constant. Otherwise, you'll get something weird. Always check your areas. All right, so let's see. I like to just separate that and then power reduction that. Like just separate them all together because integration is linear. You can essentially distribute the integral. So theta plus, so actually that's going to be minus 4 cosine theta. So that's just that first part. Evaluated from 7 pi over 6 to 11 pi over 6 plus, I'm going to power reduction this. I'm going to remove the 4. Don't forget that 1/2. So 4 over 2 is 2. 7 pi over 6 to 11 pi over 6. And that'll be 1 minus cosine of 2 theta over 2 d theta. All right, so just substituting these in, we get that. And then I'm just gonna do that in a separate line because this is kind of crazy. All right, so 2 and 2 are gonna divide out. Then we get theta minus 1/2 of sine of 2 theta with the limits of integration. Okay, so that's gonna be, let's see, 4 pi over 6, so 2 pi over 3. Minus 4 times, that'll be square root of 3 over 2 minus negative square root of 3 over 2. Plus, okay, we know that that's 2 pi over 3. Minus 1/2 sine of 11 pi over 3 minus sine of 7 pi over 3. Okay, so now let's try to combine these. I'm just going to distribute the 1/2 right now to save time and space. Okay, and then that's 2 pi over 3 minus 1/2 times, let's see, 11 pi over 3. Closest value to that is 12 pi over 3, which is going to be at 2 pi over there. If we go backward one, we get to 11 pi over 3. All right, so that's going to be negative square root of 3 over 2, and then minus 7 pi over 3. So that's going to be going, so 6 pi over 3 is the closest one, which is, again, pi over 2. Go 1 forward, we get to 7 pi over 3, so that'll be positive. So minus positive is going to be that. So be careful with all those little things. Alright, 2 pi over 3 plus pi over 3. That'll be 3 pi over 3, which is just pi. Minus 2 square root of 3 minus 1/2 of... Let's see, we can just factor negative out. Plus 1/2 of pi over 3. We're just going to give you pi minus 3 over 2 times square root of 3. Or 3 square root of 3 over 2. Alright, and that is the area. So this should be correct. Hopefully that's not wrong. Yeah. So polar areas, they could get kind of complicated once you start to actually do the integration. The main first challenge is just find the limits. Once you find the limits, you can do the integral. Then if it gets crazy, then it gets crazy. Just be careful with your integration and algebra. Alright, hopefully this was helpful, and see you in the next video.